Alrighty, guys, let's take a look at this example over here. This is, as you can see, from section 8.2, question number 10, or problem number 8.2.19. So this one is asking us, according to a study conducted by an organization, the proportion of Americans who were afraid to fly in 2006 was 0.10. A random sample of 1,300 Americans results in 117, indicating that they are afraid to fly. Explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has decreased. And then you can see the different answer choices they've given you here. So what I've done is I've actually created a spreadsheet to help us do some of the calculations in this. So you will see I've gone ahead and transferred our problem over here. So we have a proportion of 0.10. We had a random sample of 1,300, out of which 117 said they were afraid to fly. So our proportion, our p-value is 0.10 given to us in the problem. Our sample size is 1,300. And then, of course, we're talking about out of these 1,300, 117 being afraid to fly. So that's your x value. So first we need to know is that if our distribution here is approximately normal or not. So these are the two things you have to check for. We need to see if n times p times 1 minus p is a number larger than or equal to 10. And then if our sample size n is going to be less than or equal to 5% of the population size. So let's start with the calculation of n times p times 1 minus p, and you will see I just went ahead and selected the boxes here for the n and the p and then the 1 minus p calculation. And you will see when we do this math, it comes out to be 117, which of course is larger than 10. And then since our sample size is given to us as 1,300, you can see in this statement over here, I'm basically saying we can assume that this sample size is going to be less than or equal to 5% of the population size. And, they're talking about the population of Americans here. So what the population of our country is based on that. 1,300 is definitely going to be less than 5% of the population size. So once both of those conditions are satisfied, we can basically say that we're meeting these requirements, and that means the shape of our sampling distribution for p hat is going to be approximately normal. So once we establish that, then we can go ahead and find our point estimate value, which is the symbol, the p hat, right, with the little caret symbol on it. So that's going to be x divided by n, which of course is going to be 117 divided by 1,300. And you can see, again, I've put that calculation here in this box. So that's 117 divided by 1,300, and you can see it comes out to be 0.09. Okay, so once we have that, we are saying to determine if the sample proportion of Americans afraid to fly has decreased or not. So we will basically need to do this little calculation over here that you see. You can see in the parentheses, I'm saying for increased, you will use the greater than or equal to symbol and calculate the normal distribution accordingly. But since they were asking us if this has decreased or not, we're using the less than or equal to. So we want to know what is the probability if our x value was less than or equal to 117, which in our point estimate or p hat value, remember that's that calculation we did here, the 0.09. We want to know if the probability of p hat is going to be less than or equal to 0.09 or not. Okay, so we calculated our p hat. That's the same number from here that I'm just copying over here. Remember your mean for the p hat value is the same as the the proportion that we started out with. So that's the 0.10 calculation over here. And then for your standard deviation for the p hat, we actually use this formula over here. So you can see I've put both the mean and the standard deviation formulas here. So to calculate this standard deviation, we are taking the square root of p times 1 minus p and then divide that by n. And then, of course, you're taking the square root of that entire number, right? So you can see I've plugged all of these numbers here. And this standard deviation, as you can see, comes out to be 0.00832. So once you have your mean and your standard deviation, you can go ahead and calculate your z-score. And you can see that z-score formula is given us to here. So that's going to be your p hat, which is the 0.09, minus the mu for p hat, which is going to be 0.10. And then you take that difference and divide it by the standard deviation of p hat, which is the 0.0832. And you'll see I went ahead and put that in this formula, calculated that. And our z-score is coming out to be negative 1.20. And then using the standard normal distribution, or you can use the built-in function norm dot distribution, you can figure out what your area under the curve will be, right? And you can see here in the spreadsheet, I've actually used the norm dot distribution function to do the calculation for us. But like I said, you can use the normal distribution table also, which is actually given to you in the problem here in this question. So whatever you're comfortable with. And once you calculate that, you will see it gives us the value we were looking for, and it's going to come out to be 0.1147, which of course is telling us that 11 samples in 100 will result in a sample proportion of 0.09 or more. So this, of course, is an event with a probability less than 5%. So this would be considered unusual. So here we would say that it is not necessarily the evidence that the proportion of Americans who are afraid to fly has decreased below 0.10%, because your sample proportion, which came out to be 0.1147, 1147, is very close to the original proportion of 0.10, right? So we can go ahead and check that. And what did I do? Did I pick the wrong option? Yeah, sorry, I picked the wrong option. It should have been B, because this is where we're saying, yeah, sorry, which we said was unusual. My bad. So that's not necessarily evidence that the population of Americans who are afraid to fly has decreased below 0.10%. Because when we did our sample proportion, we came up with obviously the same number. So that is not a very unusual sample proportion. So just be careful about choosing the right A, B, C, or D option, but that's how you go about doing this calculation over here. So let me know if you have any questions, and good luck with this. All right, thank you.